Hi there. Okay, let's do part 2. I split this into 2 parts so that hopefully you take a breather and then come back and then we'll try some more, okay? This is also a big topic, and so that's why there's not, after we do the lesson, there's no practice stuff. We'll take the practice stuff next week. I just want to make sure that we get really comfortable with this, okay? So let's take a look on page 15 of your notes. So that feels like a lot. Okay, 15, and let's try some other examples here. Okay, so let's take a look at this can, and if we have a radius of 4.25 centimeters and we have a height of 3.8 centimeters, okay, so this would be our height, okay, and this would be our radius, okay. Let's figure out what the surface area is. Okay, so we'll get our original equation here. So surface area equals 2 pi r squared h plus 2 pi r squared. Okay, copy that down right, because sometimes that happens too. And now we're going to plug in our information. Okay, so we have 2 pi, and then the r radius is 4.25 squared, and the height is 3.8, plus 2 times pi. Oh, sorry. This is not squared. Why do I keep saying it's squared? Okay, this is not squared here. See, look, I catch my own mistakes, okay? 2 pi r squared, 2 pi, and then the radius is 4.25 squared. Okay, so now we'll do the same thing like we did with the Campbell soup example, where we'll multiply all of our rational numbers together and leave pi out of it for now. So 3.8 plus 4.25, 3.8 times 4.25 times 2 equals 32.3 pi. Okay, and then on the other side, 4.25 squared times 2 equals 36.125 pi. Okay, and because we have pi on both of them, we can then add the numbers together. So 32.3 plus 36.125 gives me 68.425 pi. And if I now multiply that by pi, that will give me, oh, that's right, this calculator doesn't have pi on it. It's so weird. Okay, 68.425 times pi equals, okay, so this long irrational number, right? Now let's take a look. We have 2 decimal places. That's the largest number of decimal places that we have, so we're going to round this to 2 decimal places. So it'd be 214.96, because the 3 is less than 5. So 214.96 centimeters squared. Okay? Now, if I asked you the question and said, hey, how much paper or wrapper, like, you know, on the outside of a can there's always a wrapper that covers the outside, how much paper would we need to have in order to just wrap the outside of the can? Okay, and that's where we need to take a look and see if we understand the equation correctly, right? We know that this part is our top and the bottom, and this is the middle, okay? The round side or the circumference. So as we're doing our equation, we can see that this would be the answer for how much paper we would need, okay? So we'd actually only have to do this part of the equation, okay? Just something to think about. Do you want to try one on your own? And then we'll check, okay? Let's do this one here. Let's give our radius is 4.25 centimeters, and the height of the can is 11.5 centimeters, okay, as if it was let's say a can of black beans, okay. So pause, try it yourself, and then check and see if you have the same answer as I do, okay? So surface area equals 2 pi RH plus 2 pi r squared, 2 pi times 4.25 times 11.5 plus 2 pi 4.25 squared. That gives me 97.75 pi plus 36.125 pi. Add that together. And then multiply that by pi. .58 centimeters squared. Okay. The other question you could ask would be, what happens if this was a cup and it needed a lid? How could we calculate how big that lid would need to be, right? So if we look at our equation, right, we know that this is for the side, okay, so we wouldn't have to look at this, and we know that this is for the top and the bottom. But if this is for the top and the bottom, so if all we're trying to do is find the lid, then we would just need one of those, just pi r squared, okay? So something to think about, okay? Let's take out our formula sheet and let's add these equations to our formula sheet, okay? So we know that one circle is pi r squared, and we know that the surface area here is 2 pi RH, okay? And this is also pi r squared, okay? So our formula for surface area of a circle is 2 pi RH plus 2 pi r squared, okay? And notice how, because these are all round sides, like they're all rounded, they're not straight lines. Although this looks like a straight line, it's deceptive, right? Because we know this curves around. That's why we have pi, right? Because pi is what we use to measure a circle, okay? Right on. Okay, now let's take this and try a couple questions where we have composite objects, okay? So I'd like to take a look at this object on the next side, okay? It says we're going to try something harder, and I'm going to show you something too, okay? So it says, to meet safety regulations, a wheelchair ramp must be followed by a landing, okay? This wheelchair ramp and the landing lead into an office building. Calculate the surface area of the ramp and the landing, okay? So here's the ramp, then here's the landing that you roll up on, okay? And from the outside, or from just looking at this, right, we can see that we have a rectangle, and it might not be the easiest thing to see with the photocopying machine, but it goes like that. Okay, and then we have the ramp, which continues on along here, goes like that, okay? Sorry for the photocopier, okay? So it's two separate objects. So to give you an example, I have here a cube. Oh, that is very big. That is very, very big. And I also have here a triangular prism. And notice how these two sides are touching, okay? So when we're doing these calculations, we have to make sure that we eliminate this side and this side in our calculation, okay? Because they're together, right? We don't actually see them, okay? So this is where thinking about the equation and what we're looking at is really important, okay? So let's give a gander at this, right? So let's make a note here. we don't include these sides. Okay. The other thing I noticed here is that it says centimeters, meters, meters, and meters, okay? Best if we put everything into the same unit. So that's the first step. Put everything into same units. Okay, so that means we're going to change our 60 centimeters to 0.6 meters. Okay. Next step, okay, we're going to find the length of the ramp. Okay, so because we know how tall it is, right? It's 0.6 centimeters, and we know that it's 9.6 meters long, but we don't actually know how long this ramp is, okay? Okay, so what are we gonna use? Well, we can use pith, right? We have a right angle triangle. Okay, we know that this is 0.6, and we know that this is 9.6, but we don't know what this is. Okay, so let's take out pith out of our pocket. So c squared equals a squared plus b squared. Okay, so c squared is going to equal 9.6 squared plus 0.6 squared. So c is going to equal the square root of 9.6 squared plus 0.6 squared. Okay. Now, to make things easier and to not be dealing with lots of decimal places, let's calculate what's underneath the square root sign and then just leave it as that for right now. Okay, so 9.6 squared plus 0.6 squared equals 92.52. Okay, so we're likely to get an irrational number from this. So let's just leave this like this right now, okay? The more rounding we do early on in an equation, the more mistakes that can happen, okay? So we'll just leave it like this for now. So now we know that this is root of 92.52, okay? Okay, next step is let's find the surface area of the ramp. Okay, so step 3, surface area of ramp. Okay, and here when we're doing composite objects, it's totally fair to do each equation separately and then add the totals at the end. It'll make things a little bit easier. Okay, so what we need to do is we need to have the area of the ramp, right? And then we need to have the area of the sides, okay? But we don't need to have the bottom or the back, okay? So let's see if we can figure that out. So the surface area is going to equal the area of the ramp plus the area of the triangles, okay? So that's going to be our length times our width plus 2 times base times height divided by 2. Okay, and we know that these 2's are going to cancel out. And let's plug in our information. So our length of this is root of 92.52 times our width is 1.2. Okay, and then we're going to add that to our base, which is 9.6, times our height, which is 0.6. Okay, hey, that's looking not bad. Okay, so let's calculate that out. Okay, so I'm going to take my calculator. I'm going to go root of 92.52 equals times 1.2 equals, and I'm going to add, and in brackets, 9.6 times 0.6. Okay, and so I get this long number with lots of decimal places. And let's see, I have 2 decimal places. That's my largest my largest number of decimal places, so I'm going to round this also to 2 decimal places. So that'll be 17.30 centimeters squared. Oh, sorry, not centimeters, wrong. Meters squared. I'm sure you were telling me, Miss Labiak, you did that wrong. Okay. Now we have the area, the surface area of the ramp and the landing. Okay. So we have the sides, the top, and the other sides, and step 4 is going to be the area of the landing. Okay, so now we have one rectangle, one square, and then another rectangle on the other side. Okay, so that's going to be, we're going to have our base times our height, plus 2 base times height. Okay, so I'm going to calculate the first one. So that's going to be our square on top. Okay, so that's 1.6. Okay, so this is 1.6 and this is 1.2. So times 1.2 plus, and then our sides, that's 2 times 0.6 times 1.6. Okay, so the big thing is making sure we set up the equation correctly, and then we can plug everything in, and then we can use our calculator to solve. Okay, so 1.6 times 1.2 equals 1.92 plus, oh, that's interesting, 1.92, equals 3.84 meters squared. Okay, so now we've calculated the 2 separate objects, and we didn't include the parts that are touching each other, and we also didn't include the back, which would be up against the store. Okay, so the last one would be our total surface area. Okay, which is going to equal the surface area of ramp and surface area of landing. Okay, so my surface area of the ramp was 17.30 meters squared, and the surface area of the landing is 3.84 meters squared. So in total, that is 21.14 meters squared. Okay. Now, if you're like, Miss Labiak, the surface area of the ramp and the landing is just the top parts. Okay? Fair. Okay? This calculates everything that is exposed. If we want to find out what just the surface area of the top part was that the wheelchair would touch, okay, I would go back to my equations here, and I would use this value, because that's our length times our width, okay, and then I would use this value, okay, area of the landing, this one here. Okay, and I would add those together. Okay, and then that would give us just the surface area of this top portion. Okay, whereas what we calculated is the surface area of everything exposed. Nothing wrong with that either. Okay, we also didn't include the bottom, right, because that touches the ground. Okay, so really important to make sure we have all of the sides that we need first. That's why we need to find the hypotenuse, because we didn't know this. Okay, and then write out our equation, and if you want to use your tenths, to write in all the variables to make sure that you calculated each one separately, totally fine. And if you're like, hey, Miss Labiak, I have a really hard time putting my equations together, I would like to do each side separately, no problem. Okay, as long as you show your work, no problem. Okay, so let's try the next one. So this was all squares or rectangles and prisms and triangles. Let's try one that actually uses circles. Okay, where we're having to use pi. Okay, I love this question. Okay, so this says 2 round cakes have a diameter of 14 centimeters, so that's all the way across, right? And 26 centimeters. Okay, and are 5 centimeters tall. So each one is 5 centimeters tall. They are arranged as shown, and the cakes are covered in frosting. What is the area of the frosting? Okay, oh, I love this. Okay, this is super fun. It's kind of like a puzzle. Okay, a math puzzle. So what do we need to remember? Well, we don't need to frost the bottom of the cake, and we don't have to frost in between the cake layers. Okay, so let's put that. Don't need to frost bottom of the cake or in between layers. Okay. So what do we need to omit? Well, we're going to have to omit the bottom of this cylinder. Okay. We're also going to have to omit the bottom of this cylinder for this one, and also another one because the cake sits on top of the bigger one. Okay, so let's call this cake A and cake B, just so we don't get confused because we're using the same equation. Okay, so let's take a look at the first one. Okay, so surface area of cake A. Okay, so we can write out our equation for surface area, which is 2 pi RH plus 2 pi r squared. Okay, and then we can see if we have everything we need, right? So we need the side, okay, right on where I have my A, we need that. We need the top, but we don't need the bottom. Okay, so I'm going to omit the 2 so that I just have 1 pi r squared. Okay, and okay, so that's good for cake A. So let's calculate that. Okay, so 2 pi and then the radius. We don't have the radius, we're given the diameter. Okay, so I have to divide that by 2, which gives me 7. Okay, so 7 times 5 plus pi, and what's my radius? 7 squared. Okay, so that's going to give me 7 times 5 is 35 times 2 is 70 pi plus 49 pi, which gives me 119 pi. Okay, so we got the first one. Okay, let's do the cake B. So surface area of cake B. So again, we have 2 pi RH plus 2 pi r squared. And these equations you start to know after a while. They get pretty comfortable. Okay, so let's see here. We need the middle. Okay, so we need this part. That's good. Now it says 2 pi r squared. So we need a top, but we don't need the bottom. Okay, so we're going to get rid of the second one. Okay, and let's fill this in. Okay, so 2 pi, and what's our radius? We just have the diameter. So I'm going to divide that by 2. Gives me 13. Okay, so I have 13 times 5 plus pi, and my radius is 13 squared. Okay, so if I calculate that out, get 13 times 5 times 2, 130 pi, 13 squared, 169 pi. Add that to my 130, gives me 299 pi. Okay, so now we have the surface areas for both cakes. And I'm sure you're saying, Miss Lavick, you're missing something, you're missing something. Aha, but it's coming up. Okay, so let's go here. Total surface area of cake. Okay, so we're going to take the surface area of, whoops, why can't I write forwards here? Let's try that again. So surface area of cake A plus surface area of cake B, okay? And what am I missing here? What am I missing? And if you've already thought about it, we still have to remove one more circle from A from the top of B, okay? Because we're covering part of the top of B with A, so we have to also subtract how big the bottom of that cake is from the top of B, okay? So we're also going to subtract the bottom of cake A. Okay, so let's write in our information here. So the surface area of cake A, we have 119 pi. Surface area of cake B is 299 pi. And the bottom of cake A, okay, well, we know that one of those is just 49 pi, right? Pi r squared. So now we can simplify this, okay? 119 plus 299 equals, and then we're going to subtract 49, gives me 369 pi. Now let's multiply that by pi so we can find out our total answer. Okay. Let me check that once more. 119 plus 299 minus 49, 369 pi. Ah, there we go. Something didn't look quite right. Okay, so we got 1,159. And we have this long irrational number, right? So how many decimal places? What's our largest decimal place that we have? Oh, we don't even have any decimal places yet. Okay, well, okay, so then let's round it to the nearest whole number. So that would be 1,159. Okay, so I can put here 2, 4, 7, 6, 8, 9, So we're going to round it to 1,159 centimeters squared. Okay, so the total amount of frosting needed would be 1,159 centimeters squared, right? Add a sentence for our word problems. That way we show that we understand what we found, okay? And that's it. Okay, so I want you to give these 6 questions a try. Give them a try. We can go over any of them together in class. 3A, C, and D, 4B, 5C, and 8B. Okay. Oh, I haven't given you the questions. They'll come for next week. Okay. I just want you to feel comfortable with this. Thanks so much.